All right, part two of yesterday. So we didn't get to finish our entire lesson yesterday. We were up to this part where everybody got confused, finding the inverse. Let's talk about finding the inverse. How do you find the inverse? You switch the x and y. That's really easy when you have a set of coordinates like this, right? Piece of cake. Then I said, okay, so like what happens when you don't have a set of coordinates and you get given an equation? How do you find the inverse? Right? This is real fancy language for saying find the inverse. The first thing you do is you sub out g of x, you put a y. The second thing that you do is you switch x and y, and the third thing is you just, isolate y or solve for y so that it gets all the way back to a normal equation, and then you just write that answer using function notation. Okay. Now, what was I doing in parts B and C? Parts B and C. What was the point of doing parts B and C? Mike? Yep, we had to substitute in. Why would I do it? Here's what I was doing, okay? So I gave you an equation, right? And I gave you the inverse. And basically in parts B and C of yesterday, what we did was we proved through algebra that they were the inverse of each other. And this right here is no accident. So now let's write the rule for determining whether two equations are inverses of each other. And so there we go. There's the rule. There's the rule. Okay, if f of g of x equals x and g of f of x equals x, in other words, when you sub f of x and g of x into each other and you get x, if you both get x for both times, then they're inverses of each other. That's a rule you just got to memorize. Anybody in here going into pre-calc? You will be asked to simply repeat this over and over again. You might as well memorize it now, right? For my class, you might see it on a short answer question. It rarely appears on the regions, but if it appears on the regions, you literally get 2 points for writing down this right here. So maybe you just want to write it down on a sheet of paper, maybe like 5, 6, 7, 8, 9, 10 times. That's what I used to do. And then when in doubt, just repeat this and you should be fine. Is anybody confused as to what it says? Anthony? What's up, buddy? What does it say? It says that if you're given two separate equations, right, and you take one equation and sub it into the other, and you get x, it turns out those two equations are inverses of each other. In other words, their coordinates, if you were to try and plot them down, are exactly switched, right? Okay. No, not 0. I said you get x. Okay, so we're going to practice this new idea twice. Here's problem number 1. Okay, practice. We're going to find the inverse first, part A. And then we're going to use compositions to justify the results. And that's what we did in the previous problems in B and C. Okay, so let's take a minute. Let's try and find the inverse. What's step 1 for trying to find the inverse? Yep, step 1. So let's do finding the inverse. So the first thing we're going to do is we're going to take this right here. We're going to make it a y. That at least helps a little bit. 2x plus 5. What's the next step after we do that? Jared. You're the man. Change x and y. Switch it. What's the third step? Kelly. Isolate y. Very nice. Right? So we're going to subtract 5, subtract 5. So we get x minus 5 equals 2y. We're going to divide both sides by 2. And you finally get that x minus 5 over 2 equals y. And so therefore, f inverse of x equals x minus 5 over 2. And that's the inverse. Piece of cake. Okay, part 2 of the problem. We're going to justify the results. So here's what we do. To justify the results, we have to prove, right, that we have to prove the following. That f, when we sub f inverse into it, what are we supposed to get? And when we do the opposite, when we take the inverse and we sub f of x into it, what are we supposed to get? Oh my God. If this takes place, the two are inverses of each other. End of story. You get what we did yesterday a little bit? Okay. So here's what we're going to do, right? Let's do the first part. Let's do this part first. We're going to do this part right here in blue. So let's, come on, please, computer. Here we go. There we go. F. Now, f inverse of x was equal to this, x minus 5 over 2. So we're going to sub x minus 5 over 2 into f. That means we sub it in right there. 2 x minus 5 over 2 plus 5. And we're going to simplify it. That's how I draw my f's. What? That's, what do you mean backwards? There you go. How about that one? I know I'm recording. So here we go. So let's simplify this, right? This 2 and this 2 cross off. You're just left with x minus 5 plus 5, which basically leaves us with x. So as it turns out, right, f of f inverse of x equals x. And that's the exact result that we were looking for. All right. Here we go. Let's do the other part of this one. We got to do the exact opposite. This guy right here, and we're going to do it in red. And so now we're going to do, oh boy, come on, computer. Don't fail me now. We only got a little while longer to go. F inverse. We're going to sub f of x into it. So we're into f inverse, we're going to sub 2x plus 5. And so we're going to sub that in. We're going to sub 2x plus 5 into the inverse. So in other words, into this equation over here, f inverse. See how it's like x minus 5 over 2? This one right here, we're going to sub in 2x minus 5 right there, and we're going to sub it in right there. Now all we have to do is simplify. Come on, computer. The top simplifies to 2x over 2, which is just x. And as it turns out, we get the same result that we were looking for, and that's no accident. And we are good to go. All right, you ready? Second part of the lesson. Super, super, super easy idea. Maybe it's like 4 level hardness. How do you find the inverse graphically, right? What's up? You could find the domain and range. What's a really important idea? If I gave you a bunch of coordinates, how would you find the inverse? Exactly. If you were given a bunch of coordinates and you were asked to find the inverse, all you'd have to do is switch them. Let's take some coordinates. If you could take some coordinates on this line and switch them, look at the picture you'd get. Let's see if I can do it. Your picture would look like this. Okay? Your picture would look like that. Now let's look through your multiple choices and see which one matches that one up. Which one does? Oh, okay, okay. On your sheet it's a little different, but it'd be D. So now what's the rule for trying to do this graphically, right? Notice I knew the answer, and I didn't actually have to use any coordinates, right? Here's what you do. It turns out the inverse is also always created by a reflection in the line y equals x. So write this down on your paper. Inverse is always created from a reflection in the line y equals x. And y equals x passes directly through the origin going like that. So this thing acts as a mirror, and take a look. Is this a perfect reflection over it? Yes or no? Okay, remember that. That's also an easy answer for this class. Your calculator, the reason I asked you to break out your calculator just draws inverses for you. Okay? The problem with this particular question right here is it didn't give us the equation. So this is really easy. All you do is put a line just like this on your paper. That's the line y equals x. Reflect the graph over, and you get the inverse. Let's take a look at the next question on your sheet, right? You've got x squared minus 4. We're going to use our calculators to do this. Break out your calculator. Okay? And here's what you do. In the y equals screen, type in x squared minus 4. Okay? Graph it. Okay? Now check this out. Does everybody see where it says draw on your calculator? Hit second, program. Draw is above the program button, right in the middle. Okay? And we should be able to go down until you see this. That draw the inverse business. Oh. We want to draw the inverse. Now, what line did we put that equation in? We put it in the y1 line. So we wanted to draw the inverse of y1. So now this is going to be the complicated part. Hit vars. Vars stands for variables. Go to y-vars, function, and we wanted to draw the inverse of the function in y1. And then you hit enter. There you go. Draws the inverse. Let's see. Ha ha ha. Get it? Let's see. Anyways, all right. Ha ha ha. Okay, let's practice. Let's play one more time, right? Do me a favor. Do the same thing over. Go try and find the inverse for this graph right here. All right. So we plugged it into our calculators. We did the same thing we did before, and the answer was D. We got one final question to answer, and then we're going to be done. What's up? Okay. Last problem of the day. On the same set of axes, sketch the graph of the inverse of this function and state the coordinates of a point on the inverse of the function. Okay. If I were you, oh, I don't know. We got a whole bunch of different ways for trying to find the inverse. How would you go about trying to do it? Gupta. You would use your calculator. The problem with trying to use your calculator is if you don't draw this line in relatively perfectly, you're not going to get points. What's up? Okay. Here's what I recommend that you do, right? Here's what I recommend that you do. We can use our calculator, but we can use our calculator in a precise way. Take this equation right here. That's negative 1/3 x plus 2, right? Let's go and try and find the inverse. So what's step 1 for trying to find the inverse? Nope. Yeah. If you have an equation, step 1 for trying to find the inverse is to switch x and y. Now, let's reorganize it. Do you know where I'm going with this? Because what I'm going to do is I'm going to find the equation of the inverse, plug that into my calculator, and then it will give me a bunch of really precise points. Okay, so then how do you clear this negative 1/3? Times it by, you could divide, I would times both sides by -3, right, the reciprocal. And so there you go. There's the inverse. -3 times x minus 2 equals y. So now we're going to graph this line. Okay, so there you go. To get the 2 points, all you